Hi, this is Kai. Welcome to another video of CS106A Homework Solutions. Today we'll be doing assignment 3, part 4. And in part 4, what we need to do is create a method that can check collisions for us. And in the book, or in the notes, it says right here that there is something called a getElementAt. And the nice thing about this method that's given to us is that if we call getElementAt, it will give us an element of something at that point, okay, that we call x and y. If it's there, you're going to return some kind of object. If it's not there, it's going to return null, okay? And so what we want to do is create a method that would return an element for us. And what we're going to do is we're going to take the ball and check the element at 4 corners. So at the 4 corners, we're going to see if there's an element there. I know this is a little bit off, but then the teacher said that since this error is so little, we wouldn't have to worry about placing the point on the curvature of the ball, but rather on the square of the ball itself. So you don't have to worry about making such a very minute calculation, okay? But rather, we're just going to cut the ball in the shape of a square and count the 4 corners and find if there's an element at any of those 4 corners at any instance, and then return an object if there is. And if there is, we're going to have it do something. So for example, if the object that it detects is the paddle, it's going to bounce off of it. If the element of the object is a brick, we want to get rid of that by removing it. Okay. So let's write that method. So the method I'm going to write is called private void, and we want to get object location, okay, or sorry, I should probably call something to like check collisions. So let's call it check collisions. That'll probably be better. Okay, and so the first thing that we're going to do is we want to use the ball location. So we're going to say ball dot get x. Okay, that will call the x coordinate of the ball, and the y coordinate of the ball would be ball.getY, like that. Now we're going to call that method that we were just introduced to. So here we're going to put getElementAt, alright, and that would give us the element at that coordinate, and we're going to check to see if the element at that coordinate is not equal to null. Okay, because if it's not equal to null, what's going to happen? It's going to return that object. And so what we want to do is return the element at that point if it's not null. Okay, and so yes. Now what happened here? Oh, that's stupid of me. I said private void. Void is when you can't return anything. Here, what we're trying to return is a G object. And why is it doing that? This method must return a result of type G object. This method check collisions from the type breakout is usually never. Oh, right. It does that because it's a conditional statement. It only does it in that situation. So to get rid of that and not to confuse yourself with, we're going to call a return null outside, so that we don't have to worry about that squiggly line on the check collisions until we finish everything that we need to get finished. So if getElementAt at the xy location is not empty, then we want to return the object that's found at that one spot. And then we also want to say else if, and then check the other spot. Else if we'll put copy and paste. The beauty of copying and pasting. Next location will be x ball x direction plus 2 times the ball radius. Oops, bar ball radius. And I like again to put these in parentheses just to show that that's one calculation right there. And then create the open curly bracket. And if it's there, then we want to return the element that is at that position, just like that. Okay, and then we gotta check the other 2 corners. So instead of the coordinate at the x, we'll do the coordinate at the y. So plus 2 times the ball radius, like that. Okay, and that would give us the object at that point, if there is an object at the bottom left corner, and then we want to be able to return it if there is something there. Okay, and you can see all I'm really doing is just copy and pasting and just trying to get everything to fit. Okay, so nothing too special here. And then there's one more. Else if get element at both at the bottom right corner, so plus 2 times ball radius. Now, people have been asking me, does it really matter if I put those parentheses over that formula? It does things in an order of operation, so it's still going to do the whole thing properly. I just have a really big habit of just putting that extra bracket on there. I know it might look a little confusing, but I just do it for, I don't know, call it insecurity. Okay, so anyways, ball.get blah blah blah, got that, and then ball.get blah blah blah, got that. What happened here? So I have an extra parentheses right there. Is it there? Oh no, actually there was supposed to be one there. There's an extra one here. There we go. And then return the element at that location. So at this, oops, crap. There you go. There we go. Okay, so if there is something there, it would check the collision, and if the collision contains some kind of object, it would return that object. If it's not there, then it's going to return null. Alright, so that's how we would check the object at that location when the ball collides into some kind of object. Okay, and now what we want to do is go back to our moving the ball. Okay, so the ball is going to check the walls, and the ball, we also want the ball to check if it's collided into some object. Alright, so here what the assignment gives us, it gives us the method they want us to create. Oh, look at that, made a mistake. They really actually want us to call it get colliding object. Really doesn't matter. Okay, but really doesn't matter, but just to stay consistent, I'm going to stick it in there. And then the object that returns, we're going to put it into a variable called the g-object, and it's the g-object of a collider. So we're going to put that, whatever that return object is, into something called collider, and we're going to check the collider values. Okay, so while true, I'm going to go ahead and put it here. I want to check my collisions, or not check collisions, I'm sorry. I want to get my colliding object right here. Okay, and it's going to return something, and we want it to return into this thing called collider. Alright, and then once we assign it to that, we want to see what we want it to do. Okay, so here, this is where we're going to put if the collider is equal to the paddle, then we want it to do nothing. Okay, actually no, that's not true. If the object that it collides into is the paddle, then what we want to do is have it reverse its y direction. So Vy is equal to negative Vy. Okay, because when it collides into the ball, we want it to bounce back up. Does that make sense? Okay, and then else, so the only thing it would collide into other than a paddle would be a brick. So instead of putting like else if, I know it's going to be a brick, so else, and then I'm going to put down what I want it to do. So let's say if it's something else, then we're going to say remove the collider, okay, because that object that we just detected is going to be a brick, so we want to remove that collider and yeah, have it bounce back. So by is equal to negative by again. All right, so it's going to bounce down after it hits the brick, and that's how we call our collision method. So now if you run the program, BreakOut, okay. Oh, there's a gObject.remove null pointer exception. Oh, okay, so it fills the collider with the null, and when we try to remove it, because there's nothing there, it's going to try removing a null. So you know what? I proved me wrong. I guess it's better just to put collider is equal to brick, because if it is then equal to a brick at that point, then we want to remove it. Now, I don't think I called it brick. I must have another variable for it. And as a matter of fact, it looks like I don't even have a brick. So here I'm going to put private grect brick. And let's see, I build bricks here. Let's get rid of the grect here, because then this brick will be referring to that brick. Okay, and it's just going to build bricks. Alright, so then I rerun the program. So now, instead of just doing else, now it's going to detect bricks and paddles and do all that stuff. Okay, so here's my, there we go, and it bounces, and okay, maybe I shouldn't have said brick. I should say something else. So I would have to put, if collider is not equal to null, then remove the collider. And I probably should also put, and it's not equal to paddle. There we go. Geez, so many small little details. And this is a thing, you know, whenever you have to troubleshoot a program, it's always good to make your methods flexible so it's easy to change things out. And that means instead of using numbers, really use variables, because if you were to use a number in your program, you would have to change it in every single spot, and that's very difficult to do. So keep in mind you want to do all that stuff. Oh, look at this. Now it's working. So now it's detecting whatever object there is at that point, not necessarily a brick. Okay, and actually I just remembered you wouldn't have been able to do that anyways, because every time you create a brick, it creates the last brick. And so pretty much in order to actually break that brick, the last brick that was called would be this brick right here. So that would be the only brick that can be that can interact with. Everything else technically is a brick, but because the instance of what a grect brick is changes every time you create one, that's why you end up with that one disappearing once you hit it. Other than that, all the other ones would just not count. And so you just keep bouncing it, you have it go through. Look at that. Nice. Now, notice how this game is very, 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 very boring and very predictable, because if you haven't already noticed already, the paddle that hits the ball will always hit it at the same angle, no matter where I hit it on the paddle. And so if you want to make this game interesting, you can actually calculate for each point on the paddle, maybe control the angle of the ball that's being the angle of the ball that's shooting off, and so that might be a little interesting. There's also another issue with the program where you might have to worry about something called sticky paddle. Sticky paddle only occurs when the ball gets stuck in between the paddles. So if you were to go fast enough and get that ball stuck between the paddle, let's see if I can do it. Kind kind of hard. You might get a sticky paddle situation. Yeah, and then it calls for like trying to improve on the program so that it doesn't occur like that. There are a couple extensions that they want you to add, which is like implementing the 3 life. That's pretty easy. That means that when the ball hits the bottom, you just take 1 life away, restart the program, and make it into a while loop. If there's enough views or enough comments saying that they want me to do that part of the breakout, then I can do that. Just not sure if people really want to see that. So just let me know and I will make that for you guys. Other than that, this is the end of assignment 3, breakout, the first project that you'll be working on. If you have any questions or if you like the video, go ahead and please like, and don't forget to subscribe, and I'll see you next time. Thank you.